Hello, hello. How's it going, everybody? Got the other kitty today that wants attention. Can you see it? No. He doesn't like to jump up on my lap so much, though. So, gonna come up or no? We're just gonna hover. Anyways, how's it going, everybody? Today, I kind of want to look at shaders. A little bit of a side quest from the other things that we've been working on lately. But we'll get back in the main quest here soon enough. I want to specifically play around with shaders in OBS. So you can write a shader that changes this. And potentially we want to pull in Naga and see how that might work with it. So there's some caveats here. We played with Naga 3-4 some odd streams ago, and that is a CLI that was created within the GFX-RS organization as kind of part of that whole group that is working on WGPU. So it's like a helper CLI to handle shaders. And it has a whole bunch of different shader options that I can read and or write. OBS uses one of those, but potentially has its own syntax. So that might be the caveats. But it would be really nice to be able to play around with shaders in a way that's safe and isn't going to crash OBS, which is why I'm interested in Naga. And potentially playing around more a little bit more with that ecosystem. Because we could do something like write a shader or helpers through WGPU and then like output a file. I don't know. But first step, let's get an actual shader working in OBS and we can kind of go from there. And we might end up keep coming back to this like shader WGPU topic. It's the like graphical side of drawing like within an app. One of the I guess alternatives to something like there's WinForms and other like more air quotes native desktop GUI clients. Well, not clients, desktop GUIs, as opposed to something like a WebView where you have the full range of CSS at your disposal. So I apparently don't have anything open. Let's fix that. Go over here, go over here. There we go. Okay, all right. Please hold. Ben, it's good to see you. It's good to see you. How you been doing? Long story short, my monitor wasn't working, so on DisplayPort, so I switched it to HDMI. And now that I've fixed it and switched it back to DisplayPort, it was not showing up. We got this. We got this. There we go. Ta-da! All right, we got it. Let's get that off. We don't need those over there. Green screen, yes, yes. We'll probably see it potentially because we're playing with shaders, and I'm likely going to work with like the raw camera source, so you might end up seeing it in a hot minute here. I don't have super controlled lighting, so the green screen sometimes looks great and sometimes looks fine. But I don't know. I don't mind it. I got a big patio window over here, so depending on the season and the lighting outside, Wisconsin lighting, it can be kind of hit or miss. The reason I use a green screen, the camera It's a nice camera, and it's got it's a 1 point some. It's got a nice depth of field. Yeah, 1.4 f-stop, which is nice. So it does the whole, like, for those that aren't into the camera thing, the f-stop is one of the things that determines the depth of field, or the bokeh. So like I'm in focus here. If I put my hand up here, you can see it. You know, we get that blurry, but you can see around the edges there when it's blurry. The blurry kind of works weird with a green screen. But I also use this for meetings. This camera I use for meetings, so it's nice to have that blur for meetings. But with green screen, it's not so great because you get that like weird blurry edge. So I ended up tweaking it. We'll see. But then with the green screen, I don't need to. My space is not as, it's a little bit more common or shared between the family than some other streamers. So it's nice to just throw a green screen up and not have to worry about that. But anyways, so the shaders, and speaking of green screens, what we want to do is we want to get OBS, a portable version, so I can't crash the stream for y'all. We want to pull in a plugin and apply a shader. I think this plugin comes with a handful of built-in ones, so we'll get that, playing around with that and see how that works. And then we'll see if we can pull in some Rust to modify that. I really need to. So this monitor here that I like monitor chat on and OBS, the color grading on it is awful. It looks like a really red. It looks fine here. Yeah, this looks fine. Okay. But when it's on my side monitor here, I look like forgot to put sunscreen on and went outside for 3 days straight. Okay, so the do I have? Yes, here. OBS shader filter. If you're at all familiar with the OBS ecosystem, Exceldro is quite prevalent, especially in the plugin space. Definitely appreciate everything that they do. They do a lot for the plugin ecosystem, which I wholeheartedly appreciate it. This was not one of their original creations, though, as I understand it to be, which is fine. But they've kind of taken this on and extended it. So what we're gonna do is I'm streaming off of Windows right now. Yeah, that's not what I want. Where do we get the portable version? Is it zip? It has been a hot minute since I downloaded the portable version. There we go. So with OBS, it is at least on Windows, it's a package that you have options as far as your how you run it and install it. There's the installer, which is a like .exe or .msi, I don't remember. Actually, exe. And it runs an installer and puts it into a program files folder. But you can also get a thing called, I don't know if they specifically stated anywhere, but it's everybody refers to it as standalone. And you get literally a zip file, and you can run it straight away from here. So if we go into, I think it's bin, OBS, yeah. So this would be something that we don't need to run the installer on, and we don't get the like registry hooks into the like deep within Windows. So this is something that you can download and run very separately from like a main install. So it's a good way to test plugins, especially if you're concerned that updates will break them. So we're gonna go ahead and yeah, we'll do it off screen. I think I will put it in. we've got a GitHub repository for the overlay. I think I'm going to end up putting it in there. Let's see how well my memory serves me. Yeah, stream overlay. And I think I have it on this computer. This is still, as far as me configuring everything, a pretty new computer. You know how that goes. All right, so we've got our stream overlay folder, and I did have it on here. I think I'm going to make a OBS portable, and we're gonna extract it there. And I'll make sure to ignore that because I don't actually want to commit that. Still doing some extracting. There's a lot of small files, so it takes a little bit to actually extract it. Yeah, I can see it's starting to go. Actually, it looks like I haven't actually committed any of this work that we were doing last time. Here, let's ignore that quick before things go too wild here. Sure, we'll put it under this section. OBS portable. Okay, so now we got an OBS within this folder, and this will be kind of our like test bed. But we can take a peek at where we were working on a handful of streams ago that I apparently never committed. Can sometimes not be great about remembering to actually get back to it and commit it. But it is what it is. So this is a WGSL, which is a type of shader language, or it's one of the shader languages. And we were playing around with making a Voronoi. There we go. Voronoi. So we pulled in a couple examples and we were making a conversion from GLSL, I think, to WGSL. And that coincides with on the website of things, there's WGL, and that is an WGL or WebGL, excuse me. I think there's a version 1 and a version 2. And the new APIs are WebGPU, which are in the same vein of WebGL. But WebGL 1 and 2 are... The spec is kind of old at this point, I think. Like 2015, I think it was WG... Or what? Oh, wow, I'm messing all these up. I think to like 2015 or so was WebGL 2. Actually, I'm curious now. WebGL. Initial release date was 2011, but I think stable release 2017. Okay. So a little bit later, 2011 for the initial release, 2017 for version 2. Yeah, you know, so typical 4, 5, 6 years between these spec changes. But as I understand it, web GPUs different and more expanded in a way that it didn't make sense to like extend this API. Because it's actually pulling in more GPU work, which is, I think this was starting to get into, but it didn't fully get there. Does it say anything about GPU support? Okay, it says it's executed on the GPU. Maybe it's something with the APIs. The web GPU spec, I'm pretty certain it started pulling in more GPU things, but but I don't know the specifics offhand. Anyways, okay, so we have a portable version of OBS. It is in our repo, get ignored. And there's a folder for OBS plugins. Some of it, as I understand, is just written as like a plugin. So that's why we have some existing, even though this is a fresh install. So like an OBS WebSocket that actually started out as a straight away as a plugin. But let's go ahead and open OBS. Okay, well, I think this will be fine. I don't know that I've actually tried to open up Portable while streaming. This is still using, I guess it still uses, does it really still use the scene collection and everything that I use? I thought Portable was more detached. OBS plugins, data. I'm a little bit scared to like play around with stuff if I have all my scenes there, but it's probably fine. And we are in OBS Portable. Is it this the zip install? Okay, here let's make sure that I downloaded the right thing. OBS Portable. I kind of was thinking that it was not so many files. Portable mode. Okay. That's old. Oh yeah, okay. Okay. That was a little bit. So we got the zip, which we did, and then I thought I was potentially missing a step. So we need to create a blank text file and name it OBS Portable. And I guess that is at the root of this. So we'll make a blank text file and do OBS Portable. So now if you go into here, we only have one running. There we go. Okay. This is like a straight away fresh install. Yeah, virtual is fine. Yep. Okay, base canvas is fine. There we go. All right. So if we go and add a video capture device, we'll go ahead and we'll end up seeing my green screen here, which is fine. There we go. So you can see it's nice to just crop out a little bit of that stuff that isn't valuable to the stream. There we go. First install as OBS Portable with just a raw video. Right. No. Here. Right there. First scene. So now we can apply shaders to this. We do need a plugin, and then we would expect to see it to show up here. We have a few plugins ready that we have an option to enable. So like this is a driver install that I did that comes with the because I have an NVIDIA GPU. And I was playing around with this, and as something potentially in addition to the chroma key type background removal, especially since I'm not really using my GPU when I stream, at least not nearly as much as if I was using it for streaming while playing video games or something of that nature. That kind of work I can always throw on the GPU. So what we need to do then is grab this plugin, and we can start playing around with the shaders. Is there a download here? I don't remember if there's a download here or not. And they did actually pretty recently just update it, which is part of why I want to come back to it and try it again. I played around with it a little bit, and I don't know if I actually really used it much. But today is that day. And feel free to ask any other OBS related questions too. Y'all in the chat. Ben, I know we've talked about OBS things a bit. I'm okay with distractions. Data, okay, so examples are where we have a bunch of our shader examples. And then textures, I believe, are related to the examples. Like the examples can pull these in. So what we need to do is basically copy these into this. Now, it's pretty common to keep the exact same folder structure. You'll see a data and an OBS plugin. So the idea is that when you open up this zip, you can straight away just like extract this directly into it. I guess I thought it might not be happy that I just did that. Did it actually show it in right away? No, okay. So we'll restart OBS. And we'll see if this plugin has showed up. Filters, effect filters. Now we should have a user-defined shader. So user-defined shader is the effect filter that you apply to any, scene or any other source effectively. And see here we're, if we would do it with this source selected, it's being applied directly to the raw source. We could also do a, so I did a little bit of crop there. We could say, sure, scene 2. We can do scene nesting where scene 2 is pulling in scene 1. And now we can also apply filters here. This scene has both a, you can see the mic and the actual like capture. Actually, the mic is coming in from global settings. So this video capture device is coming directly from here. We can do this scene nesting, but when you apply filters, you have to think a little bit about I don't know if I would qualify it as intuitive, but when you're playing around with nesting scenes, sometimes you get the effect filters and audio filters, sometimes you don't, depending on how you nest and set them all up. So it's just something to think about. But if we put it here, now it's just operating on that scene directly. And you can see that they have a like default. And I think if we hit reload, it should be pulling in this image. I don't see it anywhere though. But that's fine. I'm likely not going to actually copy and paste in here at all. I would prefer to use a file. And there's also this dot effect file. I'm not sure what or how that works. So sort of putting a pin in that to come back to it. Because there are, you can see, we've got effects. And we've got shaders. So that's something to think about. Actually, a side thought here. Did I? This is completely distraction here. I will readily admit. I did say that I'm okay for distractions. The plugin that I pulled in more recently was this vertical source. Shoot, what do they call it? etim.tv. They make a plugin to do vertical recording as a through the replay buffer. They call it. They've dubbed it backtrack. But it gives you like a whole different scene. So I can actually hit a button and theoretically I'm supposed to. This is recording and streaming to y'all. I can't point because I'm on both. I'll point to myself here. This is something I can record separately at the press of a button. But is it working right now? With the stream recordings. No. What did I do? Backtrack always on. Okay. Okay. There we go. Yep. Now it's on. I must have clicked that button at some point and turned it off so it doesn't automatically turn itself on. But I should be able to. There we go. Okay. Okay. We're good. Back to shaders. The plugin itself comes with a bunch of shaders, and just like as examples. So like let's do fire. What does that look like? Oh my. The apply damage, nice. All of these handles are in that file. And I think that's what ends up being pretty interesting because we can use OBS things or like I also run streamer.bot. We can potentially use those hooks into the shader to where we're able to change these values too. So we can do like really fast fire or not. Some of this is not as applicable. We might just want to like have this so we have a visual way to like play around with the settings. But once we get a good setting that we feel is something we want to use dialed in, we can just leave it. But these could also potentially be values that are affected by external things. So if we go ahead and look at this would be fire.shader. Is it data, plugins, shader filter, examples, and fire shader. Here we go. Section to convert GLSL to HSL. Interesting. Remember what I talked about? There's a couple different shader languages, and OBS uses HLSL. Most of what we played around with on stream is GLSL because that is WebGPU. Right? I'm questioning myself. Either way, that's what we played around a bunch on stream. So it'd be nice to just stay in one language and convert if that's something that we are able to. But these, let's see. We've got some comments up here. We have these, and this is string widget type. Yeah, widget type. Okay. This here is what's defining there's sort of like two pieces to it. There's the defining the like data type as an input, but this widget type is I don't know that it's specifically part of this language like HLSL. So it's kind of like flavored HLSL for OBS specifically. But these widget types are what, those are the hooks to understand which input things on the UI in OBS to use. So then if we look at something like what would be a good one? Fire type. Fire type should show up here within the actual shader itself. So let's take a peek at a couple of the other ones that seem interesting. And then I want to take one of these and run it through Naga and see what happens. So we've got like a doodle dot effect, right? But we don't have a doodle dot shader. So what? Like if we would do doodle dot effect, what is that going to do? Interesting. Okay, so, all right. We'll come back to that. What does this look like? I don't feel like I'm seeing any actual shadow. That one's gonna be, I think, a little bit hard to see on this. But glow might be good. Ooh. Are we sure we didn't do the drunk? Oh, there's a pulse. Doesn't seem like it's pulsing though. Okay, what else do we got? Emboss. Oh my. That's kind of weird. So these are all like different ways we can give the way the shaders work. And I'm still, I don't know that I would qualify myself as an expert. So caveats. But as I understand, shader is more about taking a pixel and processing each pixel by pixel. So in some instances, it's more performant to use a shader and do your math very much like focused on that unit, as opposed to something like SVG where you're drawing a whole object. Like your code, the SVG, scalable vector graphic, is what SVG stands for. Like your code is telling it the points and it's filling in the whole shape for you. So it's a different way to draw and handle graphics. So anytime you start to put a whole ton of objects on the screen, or you're having to manage lots of interactions, then like once you start bumping into those performance issues that come with that, that's when I hear people start suggesting looking at shaders. All right, let's see. What else we got? Pixelation. That's fun. So this is kind of like blurry type, but it's different than like there's like a pixelation type blur. But there is also literally a blur, I believe. Cartoon effect. A balloon border box. But, I thought that was a blur. I kind of want to try drunk. Ooh, rainbow dot shader. Oh my. Oh my. Let's bump down that speed a little bit. That didn't seem to change it much. Content warning, I guess. I didn't even think about that. Sorry if y'all are watching, but and we're sensitive to it, but we might have some visual glitches and stuff. I will hopefully try my best to. Ooh, yeah, see, like some of this I'm just gonna not have an idea that I'm actually gonna do it until I accidentally do it. What? Zoom. Okay, zoom. So this is like a zoom blur. Oh my. Color depth? Oh, nice. I saw a pin. Corner pin. This is kind of a fun one. I've seen this one before. You can go like this. And now I look like I'm like looking down on it. So there's shaders can be pretty powerful, but it is a little bit more of a lower level language. Some of these I kind of do want to try, but I don't know if I want to subject y'all to it. Zigzag. VHS should be a fun one. A little bit of nostalgia there. Is that showing my age? How's the VCR different? Nice. So you can do some pretty fun things here. Bent camera. Whoa. That's kind of a cool effect. Left side shadow. Want to do not size. This. Yeah. So what it's doing is we're getting a little bit of the like it makes the frame shorter and then puts a shadow. And that, I think that's one of the neat things about shaders. This doesn't seem to be doing much. One of the neat things about shaders is because it's more of a low level thing, I think you have to be, there's value in being creative about how you rate the shader, and you kind of get into the psychology of like how the brain works. So you can do things with the shader in a way that's like tricking your brain to see something. Not in like a malicious way, but like your brain sees a 2D image and is able to like process that 2D image into something that it understands as that has depth. So there's the like your brain just like doing these things subconsciously, and you can like play off of that and put these effects in a way that tells your brain that that this image, this 2D thing, is implying that there's actually depth to it. And I think that's one of the things that I really enjoy seeing, specifically with shaders. Like that ability to like play off of those inherent subconscious ways that you understand 2D images. So, is there anything else that we want to play around with? Invert Luma, that might be kind of cool. That's kind of fun. So what we could do something like, I don't know if we'll be able to, I don't know if we'll be able to hook it up very well. We could theoretically add a command to hook up to affect this, where y'all type in the chat. Like we've got this command, and this is sending a command to our browser source, and we have a browser source that has a React 3 fiber scene, which drops these 3D modeled elements that we actually modeled all those things on stream too. So we can do like chair. It's just gonna drop the chair, and we modeled that on stream, which is kind of fun. It's a fun, nice, that roll. I like that. We could potentially do the same thing with these shaders. I don't know if I'm gonna be able to, or if it makes sense to even make that all happen on stream. But I could like hook into this instance of OBS as well and send commands to it. But I don't think we're going to bother with that today. We'll focus on the shader itself. Nice. Yeah, and see, like, it doesn't even have to, like, you can just straight away ignore everything in the actual image itself. The image in those pixels, you can kind of think of it as like data. It's just data coming into it. So you can just pass through, or we could literally just have basically none of the actual image itself. Whoop. So I think with that being said, let's pull a naga and see what. Let's find a good one here that we can kind of play around with. It might be worth just doing something so ASCII. Nice. There should be a scale. Yeah, here we go. That was not what I was expecting. Oh, okay. There we go. It does have the colors in there. Why is it so huge? Like, where's here? There we go. That's interesting. I don't see anything. So like if we do extra pixels on the left. Interesting. It is definitely affecting it. I don't quite understand though why it's so zoomed in. So let's do something else. Blink. What's blink? Oh. Oh, yeah, yep, nope. Cell shaded. Oh, that's kind of fun. So like this might be a little bit too complex to pull in. get some like weird. What does that make me think of? It feels very much like horror movie type thing. Let's look through here and see if there's one that's just pretty straightforward. So this pulls in an image. I don't want to deal with images at the moment. Ripple. Okay, so this is pretty straightforward. This right here is the code that's defining those widgets. This here is the actual. It's not using an image, is it? Yeah, okay, that's using a texture. I mean, maybe it's fine. But image that sample texture sampler. So I'm guessing that if we do ripple dot shader, I don't know what the shader time does. Wow, that's trippy. I don't see where it's specifically pulling the image from. I assume it is getting an image from somewhere. Texture sampler. And part of that assumption lies in the fact that we've got this folder called textures. Is it a situation where I guess we don't specifically have anything that says is it just doing like a, is that just the return? So if we look at burn dot shader, return result, main image. Okay, I guess that's just the shader thing. I saw that and I was expecting it to be in actual, using one of those actual textures. So that is a good one, I think, to pull in. We can see that it's happening. The code is very succinct. So if we go ahead and pull in Naga, let's grab open the docs. And all these missed spam calls. Yeah, this is actually speaking of distractions, this was one of the shaders that we were trying to emulate and convert from what is this in? GLSL? To I thought we had to convert it to something. I don't know. I don't remember. Either way, this was the one that we were looking at. Voronoi are a fun thing to play around with. So let's go ahead and look at Naga. No, whoa, what? Nagawaki. Wisconsin. It's those Native American is it is it Cherokee? I don't remember. I'm not gonna commit to anything. We've got a lot. All the cities have the names are very influenced by the folk that were here before all the Europeans came over. Okay, Naga RS. There we go. We did this before. I'm gonna go ahead and do it again because I am suspecting that there's updates. We'll get a quick compile here, and then we're going to do something like okay, so we should have Naga then, because we're doing an install. And we'll do, I guess we'll do the validation. So after this is done building, we can do a Naga OBS portable. But what is it? Plugins. And 64-bit, and we want OBS shader filter. Nope. All right, let's look at it. What folder is this? My memory is clearly not serving me here. OBS plugins, OBS shader filter examples. Data, not plugins. That's where I went wrong. Plugins, OBS shader filter, and examples, and Ripple is what we're looking at. And I also need to spell naga correctly. There we go. Okay. So I ran it through and we're getting unknown input file extension. What we're seeing is an example file that came with OBS shader filter. OBS shader filter is the plugin within OBS that takes a shader and allows you to apply it to a camera or a scene or what have you in OBS. It has some of its own like OBS flavored language, and in addition to it's more of a superset on HLSL, which is the shader language. So I think what we're getting here is it's saying it doesn't like, I mean, I guess this is specifically saying just the extension. So I don't know if it's actually even looking at the file itself. So that's the next thing we're going to try here. We should I guess it's using that as a way to understand what file type it is. So if it ends with WGSL, it can make the assumption that it's WGSL. And they've got a handy little table here on what it supports. I'm not 100% certain what backend versus front end is. I think front end means that we can understand and take in WGSL and export things on the back end. I'm not certain about that. If that is the case, though, WGSL is sort of that's going to have to be our input if we want to have a workflow that includes naga. But we can output HLSL, which is what OBS shader filter expects. So what it's saying is, hey, that's not as supported. That's not supported, I believe. Which is fine. So let's go ahead and grab. We're gonna copy that. We're gonna move it up a folder and just change. Where do I put it? Yeah, let's just put it at the root. That's fine. It'll make it easy for typing in our commands. So right now it's a dot shader. If we would do like it says it can understand WGSL. So now if we did naga ripple. Okay, now we're getting it. It's saying, hey, this is WGSL because that. And it's actually parsing it. And we are getting some issues with the actual code itself, which is to be expected because we've just renamed this file, which should be a HLSL. And we're telling it to parse it and understand it as WGSL. So the next thing that we could do is, I presume that we're not going to get these inputs. So these inputs are HLSL flavored things. we might be able to write them in another language, but let's just focus on like this type of code right now. If we can grab an example from here that is, it's like in would be a good place to look. What's something that looks to be fun? Multi-view, pointers, policy, quad, array. I don't see anything that's like jumping out at me as some shader that would be fun to just drop in here and see what it does. These are very much test situations. Actually, that being said, I think they do have, must be in the main site. WebGPU? No, WGPU RS is what I'm really looking for, because on their main site they've got to try live demos. And maybe we just do something simple, even if we're not like passing through. That's probably going to be our easiest check. So if we have something like, I don't know, sure. That's a fair number of interpolate. Okay. So this would be WGSL. If we grab this and we're going to call it interpolate. Interpolate.wgsl. Now we should be able to run it on that new file, and we get a validation successful. From there, we could go naga, basically in and out. This is a little bit more involved, but maybe it won't matter. So we want to go to HLSL, and it seems to be very much the expectation is that the file name, extension on the file name, is what's dictating a lot of how this works, which is interesting. So if we do this HLSL, theoretically it should give us now the same file but in HLSL. Now it looks like we got that. So now if we could potentially pull this in and see if it actually works. So if we go back to our portable OBS with the sort of sickening user-defined shader in there, let's just do a new one. We're going to load the converted HLSL that we had. It doesn't have any of these inputs in here, so it's not going to actually change anything. Or we're not going to be able to like change the content of the shader itself. Doesn't seem to be doing much though. Which is interesting. What else do we got in here? Can we grab a different shader? We looked at Boyd's. I know what that does. I don't know how dependent it is on functions, globals. Let's try the Boyd's. We looked at that on stream. I know what it should do. And I don't know that it's going to actually affect the camera itself, but I think it's going to overwrite or just check out what's actually there. And okay, all right. Touch voids at WGSL. So now we should be able to call naga voids and voids.hlsl. So that should give us a conversion from WGSL to HSL, which theoretically is something that, if I could spell, autocomplete. This should give us something that OBS can understand. And we can go in here, find it, and it doesn't seem to be doing anything at all. Interesting. So and this is where my question around so this is definitely not WGSL. We know that. But if we called it like HLSL, I don't know if it's going to bother parsing it or trying to validate it. But we've got like this like a flavor of HLSL as I understand it. And I think that is, yeah, unknown input file extension. So we might be kind of out of luck on having it. If we write HLSL, if having Naga help us with parsing it. I don't have a good enough handle on this library to know if they're doing any other work here that would be something we could try out. It can, yeah, I mean, they've got a little flake here, unsupported but supported is in progress. They're not, that doesn't show up. So that tells me that there's not any active work going on. Now, if we did something like WGPU, could we write I don't know that it makes sense to like pull in something like WGPU because I feel like kind of the built-in expectation here is that it's going to be the thing doing the rendering rather than, in our case, like OBS is the thing doing the rendering. So really we've got these for options as input and these for options as output. Shader model 5.0 DirectX 11. So like if we would look at one of these outputs, we have, this is HLSL because we copied it. Let's close these. If we would look at interpolate, so like we can see a little bit of difference here. I mean, it might be like if it's something as much as there's an expectation that we have a main image. What's target? Let's see anything about targeting here. So if we do this interpolate, what does that look like? Doesn't seem to be doing much. Most of the work is happening here and it's just running it effectively. Oh, float 4. and it's just got an empty return. So where does texture sampler come from? It doesn't. Image. So like this might actually be part of the like file itself, where if we're writing it in like a GLSL flavored, like OBS flavored version of that, it might end up working. Reload. And we can't really go backwards. We do have a bunch of these are just like predefined basically. Is there anything else that we can pull in that we might be more confident that it's actually working? As far as GLSL tests, empty. Interesting. So, quad. We have like a visual snapshots, errors. I don't see anything as far as like visuals go. CLI. Benches, snapshots, I'm guessing are... Oh, this is not what I was guessing. That's not what I was expecting at all. So Xtask is the like runner that does a bunch of processing on files, because they have a note about it down here for development workflow. So the produce shaders are indeed valid. So that's specifically used in tests. So the thing that we're mostly seeing here is we've got WGSL, and we also have GLSL. The GLSL is a little bit more involved because there's the dot fragment and there's the vertical. The WGSL is a little bit more self-contained and it's got better support. Naga. So I think I don't know, TBD on what we would actually write something in, but let's try to just see if anything works to make certain that it makes sense. This has got a fair number of lines of code there that I would like to do something that's a little bit here. Cube array shadow. That might be fine. This is just gonna give us a cube or a bunch of cubes. So if we do touch cube array shadow .wgsl, and if we put that code in there and then we convert it, I keep writing doing NAGE. If we convert cube array shadow.gsl to cube array shadow.hlsl, it's still reasonably small chunk of code there. Now, are we going to actually see anything show up here? I think that's going to be the bit. If we can play around with it and get it to This feels like a good one to play around with, because there's not much going on. Yeah, see, I don't see anything at all. So if we look at this versus Ripple, because Ripple should still be working. Let's go ahead and confirm that this is a good file to compare against. Yep, so that's definitely doing things. It has these inputs, and then it does a float main image for data. Be in. So I suspect that we need this. And I don't see a UV anywhere. And I'm not certain how this texture stuff is going to come in or not. That might end up being the thing that the stick in the mud that we might end up being missed here. So if we would pull this in, yeah, still nothing. We have point shadow textures. It seems like it's expecting some of those words are hard. What is it? Textures. There we go. Holy wow. It's expecting textures. And that's why the code is so small. ASCII shader. We could try the ASCII shader real quick. So this, well, no, that's HLSL. It seems like we need this float 4 main image, and like that whole piece there seems to be pretty standard. So if we are looking for specifically something in here, I would like to do a shader that doesn't really require anything. Would that actually like make it white? That might be the thing that we want to try. Can we just have a shader make sprite? What's sprite? Yeah, see, like, so this is texture 2D. I am skeptical about that working as I'm expecting to be working. Vertex output location. Yeah, and see this, like, this is texture as well, which has me wondering if there's something in here as far as like pulling in those textures that changes things. Extra. So I don't actually see anything with in. Fragment in. So this is just adding colors. I say just, but if we do touch extra.wgsl and we put that in there, and I think we do need to say float, or we'll call this main image, and we're outputting a float 4. So if we would then say naga extra, not sure what we need right there. But if we do like something like this, yeah, could not parse. And like that's what I want. If we could have something like that where we can just play around with it, hit parse and let us know if is this a validation issue or if it's just something else with the shader. But if we do then extra.hlsl, no bind target was defined for the push constants block. Interesting. I don't really know what that's doing, so let's just take that out. It's entirely possible that they oh, okay. There's a pc.index, yeah. Okay, we're gonna strip. We're gonna try to make this real easy. And we're going to say, we'll leave it at that. I'm not quite sure if that's actually gonna parse as expected, but it created it. That's a good sign. So we've got a couple structs. Got a float for main, fragment input, and like these don't explicitly match, like for data v in target, but I don't know that matters. I'm pretty certain that matters though. To say main image. If we pull this in now, we'll see. So UV is doing a whole bunch of stuff. There's also this image.sample. I am not 100% certain what goes into this, but let's go ahead and see what this does. It's not saying anything specific about it, but it's possible that it's throwing an error, and I believe we would see that in a log file. So if we look, I'm possibly gonna have to look up where that is. Crashes, logs, 8856. Okay. What do we got? Missing pixel shader. 51. Unable to create effect. Errors returned from parser. Expected name, expected type. Oh, those are a while ago. So it looks like kind of this is a recent stuff here. Missing pixel shader. I don't know what that would actually look like, which is part of the problem. So we've got this. I mean, if we just straight up copied it, it should work, right? So like if we literally did this, it's gotta work. I think I can just doobly doop that out. So if we would reload, maybe it is an issue with this. Oh, Okay. So this is where it would be nice to improve this workflow, because I need to effectively keep coming back to this, leave this open potentially. And every time I load it, it says missing pixel shader. But I also have that. Yep. So this is what I would have expected to see, because I didn't define those up front. If we would go ahead and define those, it should theoretically work. Okay. That's expected. So now if we would do this replacement, see if comment that out real quick here so I can make sure I do my proper replacements here. But like vertical data isn't used anywhere. We have a v underscore in. So if we would just straight up replace these, it should still work. And I think this is something still to that. So it is specific about it. Okay. Okay. So just to confirm, we're going to reload. There we go. All right. So if we were looking to convert this, this should then be this. And I'm presuming we do need to return something. I'm going to go ahead and copy this up here. Which I suppose is exactly the same, but you know. So if we would take off, for the most part, we're just returning UV. This is doing a float. We're saying we're doing some positional stuff. Let's see if we can check the OBS docs, or at least the OBS shader filter. I think there's some expectations on. I think there's some expectations on the syntax there that isn't inherently part of the language HLSL. This explains the widgets. Here, standard parameters. The image to which the filter is being applied, either the original output of the source or the output of the previous filter in the chain. So we can do oh nice, I didn't even realize that they've got a, it's kind of cool. Several examples can be used as is or reference. Okay, the reason I stopped this is because I saw the dot effect. Note that the shader and the dot effects extensions are for clarity only. They have no specific meaning to the plugin. Text files with any extensions can be loaded. In a standard, effect files include a vertex shader and shader only as a pixel shader. That comes back to we were learning about like the differences between these when we were playing around with, I believe it was GLSL. So they're saying call it a dot shader, so then you don't have to check the box. So this is something we could think about. If we would look at one of the examples, I mean, not that big of a deal. I don't think if we go one versus the other with what we're looking to do. But if we would look at one of the examples and check out the effect, it's a little bit different. We don't actually see the yeah, so there's a vertex shader and a pixel shader. Maybe that's something we think about, maybe not. I don't know that I've got enough of a background to like benefit from choosing one versus the other, so it sounds like the dot shader or the specifically only pixel shaders is the easy way to go for the moment. So the filter should gracefully handle these variables being missing, but the shader may malfunction. So there's an image, there's time since it was created. Wow, okay. So we can get some information out of it. So you set default values as a normal assignment. Okay. Yep. That we figured out, or I knew about that ahead of time. So if we look at this, the difference between these is, so this has vert data in, oh yeah, we copied it over. I'm actually gonna move this up now just to kind of keep it all together. So this is what we had, and like this is our overriding. I'm gonna go ahead and get rid of this. It appears that it's not particularly happy if we use this. I kind of assume they were just positional arguments that we would be able to kind of mix and match them a little bit, but or like it didn't actually matter what they were named, but so we've got an in. If we do something like this, which should make this dot color. I don't know if this is actually going to work or not. It might very well be that, yeah, that's enough to break it. In which case, when we look at the logs, we would see invalid subscript color. So we've got UV size, pixel, scale, offset. It doesn't say anything about VIN. So if we would, like I don't know that this is specific. Like, does it actually have to be that? That's something I'm not quite clear on, because even if we make this switch and have this, and then VIN is this, does it still work? I'm pretty sure we tried it and I don't think it worked. Yeah. So if we would then switch this to this is just v in. Still nothing. And if we would look at the logs for that, invalid subscript UV. Interesting. So does that mean this has to be, huh? So I don't know. We've got a vn.uv, right? I don't know if we've got a way to like log out or anything. Can we do vn.uv.color? So it's doing this fragment input main that has a color on it. And that's kind of the, I think it's gotten a lot more stable. I think it, like this kind of stuff used to crash it, which is good. Not the crashing part, but the stability part. So like I could potentially actually just do this straight up on stream and not worry about like in my main streaming OBS and not worry about crashing it. So even with just this, are we getting, okay, so this technically doesn't seem to matter. And if we would do this replacement, it does seem to matter. I don't actually need to replace it here, but just to kind of keep it all consistent. Yeah. So it seems very much attached to this VN. That it has to be VN. Can we do a HLSL debug log? Interesting. It seems that use a render doc. I made it the wrong button. Sorry. Press the. I caught the mute button, but it was the wrong one. Oh well. Oh. Interesting. Interesting. So let's play around with shaders more directly. That might be something that we look at. I think I'm gonna poke on this just a little bit more, and we're probably gonna call it a day. Doesn't seem like the target actually matters. It does seem to be very specific around this, but I don't have a good feeling for. There we were changing. That's what we could do. Let's look at another example. Here we're changing. We're doing more spatial type stuff. Something like color depth maybe. Change maps UV into the grid. Okay, so that's pixelation. Okay, blink might be the clearest. Here we are returning a float, and it's just straight up colors. The last one is alpha transparency, I'm presuming RGB, red, green, blue. And then color.a is the alpha transparency. So this will give us the color. If we would do interesting. So if that gives us the color, it's returning a float 4. So we got RGB here. And if we would do this blink is actually really helpful. Because what it's doing is just straight up returning, so like an image dot sample is returning a float 4. So we don't need to necessarily do the image dot sample as this last piece. This is just grabbing the existing color, and then we're shifting it here. So if we would do something like this, we've got no alpha now, which would make it visible. There we go. So in here, I think this is a, is this just an int? So if we would do something like 30 to like color shift the red. Yeah. And you can see here, it's affecting everything. So we cropped off, we cropped off the sides. I guess this would have been easier to do. Those are also getting colored. Something to think about when you are determining like what to put, like where to put your shader. Okay, so like this being said, if we have a really small example and we look at so this is taking in that color. This is a struct and it's defining the struct. So if we could get like a struct that represents like what this is, that might help us out quite a bit. We might actually have to back into that though. And I wonder if somebody's done that work before. And I also want to play around a little bit with like, if we would use this as a way to write a shader, verify it, and then load it in after the fact. There might be some value to like justifying a specific language over another. And that also comes back to, do we write straight away in HLSL, even though the workflow isn't great? If we can't like improve this kind of stuff, I don't want to have to like, I want to run a conversion. I want to have it do the conversion. And then I want to just load it straight away. If I can't do that, then yeah. So this just have, so there's the fragment in, fragment input main, which is where this is coming out of. Location 0 is fragment input main, I'm presuming, of which it's a color is defined here, or is defined by that. So I think we can potentially make it work, but I think this is what we're going to call it. We got some done. We got some work done. We were able to run a portable. We were able to run a portable version of OBS. We were able to pull in their example shaders, run Naga on the, I guess, the examples from Naga, because HLSL is not supported as in the front end of Naga, so it can only output. So if we're going to use Naga for anything, it will need to be written. Our shader will have to be in a different language, and we'll have to do a conversion process. And that conversion process might not be very straightforward, in which case that's probably going to push us towards not using Naga in any workflow. Just a little bit unfortunate. But we'll probably continue to play around with it. We'll probably play around with more shaders and stuff on stream in the future, but it's not going to be in regular content necessarily. I do want to get back to some of the lower level Tori pieces, which is the basis for some of the playing around with WGPU. Because we're talking rendering. And if we're talking rendering in the context of Tori, we have a built-in expectation of a render target or renderer in Rye. So we're going to get to it, TBD. But this stuff isn't too off the wall as far as topics go and general content. And it's kind of fun to play with shaders. I kind of enjoy it. So we'll continue to pick it up occasionally in between other things. And with that, I think I'm going to leave you to next time. We should be good for next Tuesday. I don't think I've got anything, but I am taking vacation at the end of the week, or from tomorrow on, which is going to be very nice. It's good to be to relax every once in a while. So I will catch you all next week, Tuesday, same place. Well, yeah, same place, I guess. Same place, same time. See you next week. Bye.